Hello, Keith Rucker here at VintageMachinery.org. Guys, today I've got a little project that we need to do for the Georgia Museum of Agriculture, which I help out a good bit with various projects over the years, and they brought me another one here to help keep some of their antique vintage machinery up and running out at the museum. What I've got here is a clutch plate off of their steam-powered sawmill. Their sawmill is made by the Deloach Company out of Atlanta, Georgia. It was made back in the late 1800s, 1890s, I think is when that sawmill was actually built. And it has a rather unique drive system on it where there's actually some discs like this right here that go up against a flat plate, and the friction between the two is what helps to drive the saw blade and the carriage and so forth. And it also helps to transfer the power at 90-degree angles. So you got a shaft that's actually turning the saw blade, and then we need to actually switch that over to a 90 degrees and then 90 degrees again into a clutch that moves the carriage back and forth. And there's two of these friction plates that do that. So what you got here is a plate that has this, what I call friction board in it, and that goes up against another plate, and this plate's running. It just has the friction between his, and that the friction between the two actually will transfer the power between them. Over the years, the friction board in these plates will wear down and eventually has to be replaced. And this is something that we have to do periodically, usually about once every 10 or 15 years. It's not something that I have to do a lot, but one of the friction plates had just kind of gotten to the point where it needed to be replaced. And they brought this to me. Now, it's already been partially done. They did this at the museum. They actually took this friction board that's in here, and I'm going to say this is kind of similar composition to, like, if you've seen the pegboard or something like that. It's a little bit different, but it kind of looks like that. But this is actually made for friction, and this is also used on flat belt pulleys and things like that, that they would just machine this stuff out. Back in the old days, they actually would have made these out of paper. This friction board tends to work a little bit better. You can still get this friction board from different places or what have you. They had some in stock. They went ahead and cut the disc out and bolted them all together here. But the job that I need to do is I need to actually turn this and get it round and smooth over on the lathe. Because right now it's just a rough circle cut in there. It's not all flat all the way across. We need good friction between the two. We need to have good surface area for it to come in contact with. So game plan here is we need to get this over onto the lathe and get this turned where it is running true to the shaft in here. To do that, I think what I'm going to do is actually make a mandrel to mount this on so that I can put this on a shaft in the lathe. The shaft that this goes on was big and had to really take a lot of stuff off. It was going to be a pain to bring the whole shaft in. So I'm just going to make a little short mandrel that we can just mount this on and get it turning over in the lathe where it's running true to that shaft. And then we'll just put this in the lathe and we'll cut this off and get this turned down nice and round like it needs to be. So let's get started on it. Just a closer look here. You can see there's basically just a flange with a hole in it. Got the bolts going through it. Same thing on the other side. Just sandwiches all this together. The bolts go through it and sandwich it all together. And they got the fiberboard or friction board cut out in a circle. They need this turned down to 9 inches in diameter. I can't remember what size it is originally here. I think they did it about 3/8 oversized, about 9.5 inches. So we got a little bit of material to cut off. Let me go cut a piece to make the arbor out of. Let's see, this is 6 inches. I think I'll cut a piece 12 inches in diameter, and let's see what size that is. I think they said it was 1 5/8 inches, if I remember right. Just verify. Yeah. Just a tad over that. Got a little wear in it, but no big deal. All right, I think I got some 1 5/8 inches stock. I'll go cut a piece and we'll make an arbor. And here's some shafting that I found. And yeah, there's a set screw back here that I need to back off. I do need to cut a key in here to drive it with. Let me mark where that needs to be and figure out what size that is. That's the key. Looks like 3/8, 375. And let me see. Do this. I think what I'll do is we'll turn this, or cut that key out here on the end and just go in about, yeah, we'll go in about that far with the key. And I need to take this over to the lathe. I need to put a center in one end of it, and I need to cut that keyway in it. Probably just go ahead and face both sides of it while I'm at it. All right, let's fire up the lathe. The lathe will come in here and face off this face here. And while it's probably not needed, I'm just going to go ahead and flip it around, and we'll face off the other end of this shaft as well. That's as far as it'll go before it hits the back. It won't fit up through the headstock. This end doesn't need a center because it's going to be chucked into the chuck to drive it, unless we wanted to do it between centers, but there's no reason to do that. All right, let's go cut our keyway. All right, we're getting set up to put this keyway in here. First thing I need to do, I got my shaft in the mill. My vise is trammed in, so it's square to the table, all that. I need to find the center of the shaft. And to do that, I got an edge finder here. I've shown this many times. We'll go ahead and just find the edge on both sides. We'll zero out the digital readout on one side and find the edge, zero it out, go to the other side, find the edge, and then we'll divide that number in half on the digital readout, and that'll put the spindle right over the center where we can cut our keyway. All right, we'll come in with our edge finder. And I need to come down a little bit more with my, there we go. Now when that starts touching it, it'll eventually go in, and all of a sudden it's just going to move over to one side. I'm moving my table real slow right there. Now the edge of this is parallel to the edge of that, or right on the edge of it. I'm going to zero out my digital readout. We'll go up. We'll go over to the other side. Again, my DRO has been zeroed out. Too far down, there we go. Same thing. Boom, right there. We'll stop the mill, and now we'll figure out where we are on the digital readout, put it in the center. So you see my measurement, that's how far from edge to edge. I won't need to divide that in half. I can do it manually and just dial into it, but this DRO will do it for me. So I'm just going to use my half function right here. It's going to ask me to select which axis. It just divided that number in half. So now I just need to take the table to that reads 0. And when it does, I'm right on center. So I'll get fudged around here, get that worked out right on the middle, and we'll be where we need to be. We got our end mill right over the center. What I'm going to do is I'm just going to drop this down until it just touches the top there. I'm just going to let it sit right on the top. I'm going to call that 0. And this is a 3/8 inch keyway, so we need to basically make our depth of our cut half of 3/8, which is 3/16, which is 0.1875. So what I'm going to do again, I've got my digital readout zeroed out here. I'm just going to dial in. I'm going to do this all in one pass. So we'll just dial up 0.1875. 1, 2, 3, 4, 5, 6, 7, 8. 1, 8, We'll go 7.5 right there. We'll lock our table, lock our knee down, and we'll just feed in right there. Here we go. I'm just going to go down here to the line that I have drawn in there. Go. One keyway. And I'm going to take this little tool here. This is for deburring keyways. That just takes the little corners off. This is a tool made by Noga. Really handy for that exact purpose right there. All right, our keyway is cut. We're ready to put our arbor on the lathe and put our piece on there and turn our shaft down, or our disc down. So now I'm going to take my shaft, see if we can slide it up into this. It's a little tight, but it's going. Let's see. There we go. And I got a little bit of a misalignment. All right. Yeah. That did it. And now we will tighten up our set screw, and I don't know why we have such a long set screw in this. So we had this really long square head set screw. I'm just going to replace it with a little bit shorter one. There's no reason for that extra height sticking out of there. That's just something that can grab a hold of something while this thing's spinning around and make a mess out of something. So we'll just put this new one in. All right, this is ready to go over on the lathe. I'm over here at the big Monarch lathe, and we've got this set up now with the mandrel that we made chucked up in the lathe. Of course, we're supported down here with the tailstock in with a live center, and I need to put that in there good after we've got the front adjusted, so that's supported. And we need to put a cutter in here to cut this, and I just ground this cutter here just a minute ago. Because this is kind of a papery, real soft material, I really kind of made something that's kind of a knife edge with a pretty sharp edge on it that should hopefully just cut right through that. And I'm just going to mount this over here in the tool holder. We'll get this tightened up. We need to raise that up a little bit to kind of get it closer to center there. And I think we are ready to go. This needs to be turned to 9 inches in diameter. It is not a critical measurement by any means. I think we're at about 9.5 right now. I need to get my big set of calipers, and we can kind of make some measurements on this as we go. So let's get it cut. Here, and just going to make a little light cut across here, kind of figure out where I'm at in the diameter. All right. See where I'm at. Like we're about a little over 9.5 inches. And I'm taking 100 thousandths off the diameter. We did speed up our feed rate here. That's pretty good there. make another pass. I got you zoomed out because this thing's throwing this chip down here. Anyway, I thought it was kind of cool. It's all kind of piling up right down over here. Hopefully you can kind of see that. Of course, this material is pretty soft, so it's cutting pretty easily. Hopefully I can keep it over here and kind of out of my chip pan. Make it a little bit easier to clean up. Make another pass down through here. Just going to use a micrometer here to measure this. I was having trouble kind of getting that caliper completely over it. And again, the measurement's not critical, but they said 9 inches. Try to shoot for here. All right, we're at 1 inch, 25, 35, 40. So let's take another 100 and then we'll finish it up. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 off the diameter. We're at 25, 35, about 45 thousandths to come off. This should be our final pass. Double check our measurement here. About 3 thousandths oversized, which is well within tolerance. We don't have to be anywhere that accurate. Where this tool came out, it kind of folded over that edge. So I'm just going to kind of come in here with a razor blade and just kind of trim that up. All right, that's got that cleaned up fairly good. It got a little bit of an edge over on the other side. I may work it out as well. These edges kind of mushroom over with time anyway on the machine, but that'll work just fine. I think we're ready to pull this out of here, and this job is pretty well done. Now we got that out of the lathe, and I need to get this shaft out. I just got this over at the arbor press. I've already loosened up the set screw over here on the side. That was a little bit tight going in, but it should press right out here with the arbor press. I got the key is still in it. There we go. So we're out here at the Georgia Museum of Agriculture at their steam-powered sawmill. This is the Deloach sawmill made in the 1890s, and has the part on there that we just worked on. So if you look, you got the main belt right here. That goes up to a steam engine. We got a boiler over here on the right, and this is a Atlas 25 horsepower steam engine that we power this sawmill with, and it's belted up. As you can see, the belt goes down and to the husk frame, the saw frame, and you got a pulley here with a shaft that goes straight out to the saw blade. That saw blade is turning, but then we also got to power the carriage off of this. The carriage, of course, is where you put the logs on and go back and forth. You got to be able to control that. And the way on this sawmill is, this is very different than a lot of your more modern sawmills that are cable operated. You got this big disc right here, and then off of that, this is our little paper pulley that we did that goes up on there. It's just a friction. So that pulley runs up, or that whatever you call it, it runs up against the other plate, and that turns the motion of the shaft here by 90 degrees. And then up here we've got another plate and another friction roll. This is one that I fixed probably 10-15 years ago. Did the exact same thing to it. This one then comes up to a rack and pinion. It goes down. There's a rack and pinion up underneath the carriage, and that's what moves the carriage back and forth. This one here is adjustable speed, variable speed. So hang on a second. Sorry about that. I'm doing this one-handed. But you move the handle back and forth, and depending, when you're in the center, it doesn't move at all. But as you come forward, it's going to increase the speed as you increase the diameter of the wheel that it's going against. So right here, the carriage is moving real slow. When you get out here toward the end, it's moving real fast, and you can back it up, go the other way, and that reverses the carriage. So this is a variable speed clutch. Deloach actually patented this clutch mechanism, and for some of you older guys out there that remember the old snapper lawnmowers, same type of speed adjustment as was on the old snapper lawnmowers back in the day. And actually I found it interesting that the Deloach Sawmill Company was up in McDonough, Georgia, and that's where Snapper also was. So I kind of always wondered if there was a relationship between Snapper and Deloach, but this is the same thing there. So anyway, I wanted to show you guys the pulley that we did, or this drive clutch, whatever it's called, friction clutch. I wanted to show you that installed on the sawmill, where you can actually see this going. And we're actually going to be running the sawmill this weekend. I think this video will post on a Wednesday, and then we're going to be running the sawmill on Saturday. So if you guys are local, and of course you're watching this when it first comes out, want to see it run, you can head out to the Georgia Museum of Agriculture in Tifton, Georgia. And we're going to be running the sawmill this weekend and doing cane grinding, running our steam-powered cotton gin, running the steam-powered train, of course. All that's be going on this Saturday for anybody that wants to come out and join the fun. So there'll also be some antique tractors here and some other stuff. It's a nice little fall show. Anyway, I thought I'd show that. Well, guys, I think that is going to be a wrap on this one. Just a quick and dirty project. Sometimes they're easy, sometimes they're hard. This one was not too bad. Probably took as much time to make the little mandrel to turn it on as it did to actually do the job. But we'll get this, like I said, out to the museum, let them get it installed back on. Hopefully you guys will have already seen the video where it's on the sawmill, but I'm shooting up the finish now, but I'll try to get that put in there if I possibly can. And with that, guys, that is a wrap. As always, thanks so much for watching. Please do subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon to get notifications when new videos are posted. Please leave those comments. Please leave that thumbs up, and please subscribe if you haven't already. And again, as I always say, a big, huge thank you to those who support the channel financially through Patreon and PayPal. It really helps me out a lot. This is my full-time gig now out here making videos for you guys. So I got to make a living doing this, and anything helps there as far as us go. If you get value out of these videos, please consider chipping in a little bit. Like I said, the links are down in the description below for Patreon and PayPal to help out around here. And with that, guys, we're going to sign off. We'll get out of here. We'll catch you on the next video. As always, thanks for watching.